Great. Martin and I are doing the review questions for Module 12. This video begins with review question number 5. Please read it to us, Martin.
What are the properties of an ideal gas?
So those are written on page 394 in the text. They're written in bold because you have to know them. And they're reviewed in this review question so that you can practice giving them to me. How many properties are listed, Martin?
3.
What's the first one?
The molecules that make up the gas are very small compared to the total volume available to the gas.
Okay.
The molecules that make up the gas must be so far apart from one another that there is no attraction or repulsion between them.
Okay, so molecules are far enough apart for no attraction or repulsion. And number 3.
The collisions that occur between the gas molecules must be elastic. In other words, when the molecules collide, no energy can be lost in the collision. Also, no energy can be lost when the molecules of the gas collide with the walls of the container.
So elastic collisions, no energy lost by collision of molecules with each other or the container.
Under what? Okay, 6.
Okay, did you get all that down?
Yes.
Great. Number 6.
Under what conditions do gases behave ideally?
Okay.
At standard temperature and pressure. High temperatures and low pressures, actually.
The gas or the temperature that is, yeah. Okay. Gases behave ideally at or near STP, standard temperature and pressure. Does number 7 ask us to define STP?
Wait,
or should we define it now?
Yeah, no, 7. What is standard temperature and pressure?
So, what is the standard temperature?
273 degrees Kelvin. And 1.00 atmospheres.
Good. And you have to remember that for the test. It probably won't be given you what this is. You need to remember it's 273. That means it's precise to the ones place so that when you're adding or subtracting a delta T, make sure you have the right precision, okay? and the atmosphere has 3 significant digits, right?
Yeah.
All right. And now we're looking at number 8.
You can read it yourself. 2 steel containers of equal volume contain 2 different gases at the same temperature. The first container holds 1.3 moles of nitrogen gas, that's N2, and the second contains 1.3 moles of SO3 gas. Compare the pressures of the 2 containers.
So to do this, we're going to look at the ideal gas law, right?
Yes.
The pressure, the volume, the temperature, the ideal gas constant times the N. What's the N?
That's the number of moles.
That's right. So let me ask you, do I have the same number of moles?
Yes.
What is different in these two things?
The gases.
So
No, we're not actually using the ideal gas law. We're using Dalton's law.
Well, let me just make sure you understand something. They have the same volume, right?
Yes.
They have the same temperature. They have the same number of moles. The ideal gas constant is the same. So what can you conclude?
That they have the same pressure.
You can conclude that they will have the same pressure because all of those things are the same. So remember, PV equals nRT. So if I'm trying to find the pressure, I'm going to say nRT over V. The V is the same. The N is the same. The R, obviously, it's a constant. It's going to be the same. The T is the same. Therefore, the pressure of both of these gases will be the same.
Yes.
Okay, so that's what we can conclude. Okay, that's it for this video. We're going to come back with a final video for 9 and 10.